This is Vijay Kalwa. I'm here to give a brief session on design and development of solar powered air cooler. I would like to thank IJSR for providing the platform to share the knowledge. Here we started working on present air cooling methods, and especially we got inspired by a Meticool product. You know that Meticool does not make use of any artificial resources, and it does the cooling of product with available of natural resources and without any external power supply or anything else. Similar way, we thought of adding something to that and combining artificial resource as well as the natural resource and develop one product that is solar powered air cooler. Here the title is only for the air cooler, but application we have added one more thing so that we have provided a small space in our product so there they can store some of the vegetables or some household items. And here
Thank you for those who joined in.
the problem we identified is that most of the electricity generation is done with the help of coal. And in a graph, you can see that it's of 41.0%. And hardly we make use of non-conventional energy sources. And because of this, right, because of this, you can see that electricity generation, because of coal, produces oxides, sulfur dioxide, and some hazardous emissions, right? Emission of carbon dioxide, which may contribute to the climate changes, right? Weather changes every day, day to day. So maybe a small contribution to reduce these all emissions, we can come up with some of the conventional energy resources. And solution for that, that solar energy or radiant light, heat from the sun, is harnessed using some of the already implemented technologies, that is photovoltaic effect. And Earth receives approximately 174 petawatts of incoming solar radiation. And out of this 174 petawatts, 30% is reflected back because of the atmospheric molecules and all, and rest is absorbed by the clouds, oceans, and masses. And to utilize this one, that photovoltaic is the only effect or only technology that can utilize this solar radiation. So for the utilizing this photovoltaic technology, we want to build a powered air cooler. And objective was simple enough to make aware of non-conventional energy sources to reduce environmental pollutions and to provide solution for power cut problems in our villages, right? And to replace existing costlier and high energy consumption cooling methods. So to come up with this or to clear these objectives, we need such a source which is abundantly available in nature, which does not impose any bad effects on Earth. And to do this, there is only one thing which can come up with these all problems is solar energy. So to build the product, air cooler, solar air cooler, we have considered some of the considerations, right? The main thing is the space to which area you want to build a cooler. And you know that we need to come up with the proper space. For that, we should start designing. The first thing we have considered a room with a specific area, and we started calculating the amount of heat entering into the area. Once we once after getting this amount of heat entering into the area, we thought of ejecting that amount of heat. So to eject that one, we need electric motor, a capacity. And then with respect to that, we have calculated capacity of the fan required. And after that, based on the capacity of the fan and the electric motor, we have selected the capacity on the specifications of solar panel and the battery. Here we have some thermal equations for calculating the amount of heat entering into the room and what capacity of electrical motor required to eject the heat. For example, uh, we have taken here 3 meter cube of a space for the calculation purpose or to build a prototype model. And after that, we have calculated the amount of heat flow from the area and the amount of work done in a specific area. Based upon that, we have selected the capacity of fan required. And after that, once after getting the capacity of the fan in a watts, we have selected to run the fan what amount of solar panel, what capacity of a solar panel is required. And once after harnessing the power from a solar panel, we need a battery to store that one. So based upon that, we have selected even battery, and we have selected one more instrument, that is charge controller. And you know that the solar radiation is all the time, it's fluctuating, it's not a constant power generating, it's continuously fluctuating. So to safeguard the elements of our product, we have used one instrument called charge controller. And here you can see complete setup or overview of our project, right? We made use of a solar panel to connect this to the our product. Here you can see the layout of our product. Upper part of our product is a solar air cooler, and below, just below that one, we got a cooling cabin. And this cooling cabin, we try to implement or reflect something like Miticool, right? Miticool is made up of completely clay or a mud. Now here we produced some ceramic slabs, and we try to make continuous flow of water so that we can cool this cabin, so this bottom space can be utilized for placing any vegetables or household items, and the upper part, the cooler, which is run by the again solar panel to the charge controller, to the battery to store the power, and from there to the inverter, right? And at the top of this, we have provided water sump with a pump so that it can continuously run the water from top to the bottom. Conclusion, uh, by looking at the advantages and disadvantages of product, we want to conclude that cost of this solar powered air cooler, the existing products in the market, which looks which appeals better and affordable by the common people. And you know that solar product perfectly suits for villages because of power cuts, and schools, especially offices, and thus prevention of the power cut problems. And this product comprises of many attractive features such as usage of solar energy, and making aware of non-conventional energy resources, and cooler and cooling cabin at a lower cost. It is eco-friendly, natural, and electricity savers, and overall it's a power saving product. Here are some of the references we have taken for building the product. And thank you, IJSR, for providing the platform. And thank you, everyone.